Part 7. Van de Graaff generator. The Van de Graaff generator continuously produces static charges by friction. A rubber ball carries charges to the dome where a large amount of charge is accumulated. Let's take a look at the experiment 1b to see the action of Van de Graaff generator.
This is a Van de Graaff generator. It has a rubber belt which is driven by a motor. The rubber belt rubs against a plastic roller and becomes charged. The charge is carried by the moving belt to the metal dome where it is collected. A large amount of charge is therefore built up on the dome. A small conducting polystyrene ball is suspended from an insulating rod. The ball is brought near the dome. Watch what happens to the ball. Why is the ball attracted to the dome but is then repelled on touching the dome? The insulating rod is fixed on the dome. Watch what happens to the ball. Some conducting polystyrene balls are put in a plastic container with a metal top and a metal bottom. The container is fixed on the dome and the metal top is connected to earth. Why do the balls move about? A head of hair is fixed on the dome of the Van de Graaff generator. Watch what happens to the hair. Why do the hairs stand on ends? A girl standing on a plastic stool touches the dome. Why do her hairs stand on ends? The girl now steps on the ground. What happens to her hair? Why? A girl standing on a plastic stool touches another girl also standing on a plastic stool. What happens to their hair? Explain your observation. A girl standing on a plastic stool touches another girl standing on the ground. On touching each other, both girls receive an electric shock. Why? What happens to the two girls' hairs? Explain your observation. A metal sphere is connected to the Earth. The sphere is placed near the dome of the Van de Graaff generator. Why are sparks produced? A girl standing on the ground is holding a metal sphere in her hand near the dome. Why are sparks produced? The girl, standing on a plastic stool, touches the dome with one hand. She points her finger a short distance from a Bunsen burner. The burner is connected with a piece of wire to the earth. Watch the sparks produce. How is the burner lit? The dome is connected to the Earth via a light beam galvanometer. No sparks are produced this time, but the galvanometer shows a reading. Why?
We will study the electric field patterns between electrodes in the following experiment. This is an electric field pattern apparatus. It is placed on an overhead projector. There are 2 electrodes in the dish containing castor oil. Connect the electrodes to an EHT power supply unit. Sprinkle some semolina on the oil. Switch on the power supply and set the voltage to 5 kilovolts. Watch how the semolina particles line up to show the electric field pattern. Repeat with electrodes of other shapes. Observe the electric field patterns formed. This is the electric field pattern formed by a straight electrode and a point electrode. This is the electric field pattern formed by 2 point electrodes. Now, the point electrode is still connected to the positive terminal, while a circular electrode is connected to the negative terminal. Observe the electric field pattern formed. Next, connect 2 point electrodes to the positive terminal and keep the circular electrode connecting to the negative terminal. What does the electric field pattern look like this time?
The following explains the observation in the above videos. The video at first explained the structure of a Van de Graaff generator, and then you can see there's a conducting ball which is attracted to the dome to share the charge of the dome, but after that, having the same charge, it is repelled. Next, there are some conducting balls put inside a plastic container, which has a metal plate at the bottom, touches the dome. When the Van de Graaff generator is turned on, these conducting balls are charged by sharing. When these balls jumps up and down, when they touches the top metal plate, their positive static charge is carried to the top metal plate, and so a current flow from the top plate to the earth. In the next video, you see the hairs all stand up at their ends due to the repulsion between the similarly charged hairs. The hair of the first lady also stands at their ends. And what is more interesting is when there is a second lady who put her hands on the shoulder of the first, and at that time you can see that they both get an electric shock. And then for the last video, the dome is earthed through a gravilometer. Between the dome and this metal sphere, there is only a short distance of air. When the dome carries enough charges, there will be spark between them, so that static charges on the dome jumps to the metal sphere on the right, and that charges flow to the earth, and that produce a current on the gravilometer. And the experiment may be done in this way. Without the wire, we use a human body. In this way, she used her body as a conducting path, so the current passes through her two hands and jumps to the earth through the Bunsen burner. The spark that produced at that time may then elit a Bunsen burner. Fascinating, right? In example 4, a girl touches the dome as static charges build up. Note that she must touch the dome before the rubber belt starts running, or else she may get an electric shock. Anybody who touches a charged body may get an electric shock, as charges are shared and flow between the two bodies. Electrostatic precipitator and air purifier both make use of electrostatics to collect ash and smoke particles in air. In an electrostatic precipitator, the negative electrodes charges the small dust particles negatively, which are then attracted to the positive plate for collection. A similar mechanism applies to household air purifier, where the small particles are charged and they are captured subsequently. Now please do checkpoint 3. Electric field. Like charges repel and unlike charges attract. When a charge experiences the electric force of the other, we say that it is inside the electric field of the other, just like an apple experiences the gravitational force of the earth because it is inside the earth's gravitational field. Of course, the earth also experiences attractive force by the apple, so you may also say the earth is inside the gravitational field of the apple at the same time. A. Electric field lines. Similar to gravitational field, we use field lines to represent electric field produced by a charge. The direction of the field lines give the direction of electric force on a positive test charge, while the density of the field lines gives the magnitude of the field strength. The electric field produced by two opposite charges is shown here in figure 1.1z. When the positive test charge is placed inside the field, it experiences a force and resultant force due to repulsion by the positive charge and attraction by a negative charge. Without an initial velocity, the test charge will be pulled along the field line instantaneously. Note that if a charge has an initial velocity, enters an electric field, it will not move along the field lines in both cases, unless the velocity is along the field line direction. For example, when you throw something horizontally into a gravitational field, it has a horizontal velocity. It experiences gravity, but it does not drop directly to the ground because it has a horizontal velocity. It follows a projectile motion. So the field provides a force, and that produces an acceleration. So, field line is not necessarily a path of motion. B. Electric field patterns. Experiment 1C demonstrates how we may obtain different electric field patterns produced by different charge distributions. The EHT supply is used to charge conductors of different shapes. In the experiment, ceremonial grains align themselves along electric field lines. Ceremonial grains are first polarized, so that each forms with a positive and a negative end. And so in this way, the grains align themselves head to tail between the electrodes due to the action of the electric field. 1. Electric field around point charges. The electric field around an isolated charge, whether positive or negative, is spherically symmetric. The field is stronger near the charge and weaker when further away. For two charges to form an electric field, the field patterns are shown below. Note that there is a neutral point for a pair of similar charges, where the electric force due to the two similar charges cancel out each other. 2. Electric field between two parallel charged plates. Electric field between two metal plates carrying opposite charges produce a uniform field between the plates. A uniform field has the same field everywhere inside the field, same in both magnitude and direction. The field lines are parallel and evenly spaced. In the next chapter, we will further investigate electric field in terms of its magnitude, and there are some useful formula to be introduced. Now try checkpoint 4 on the next page.